All right, everyone, welcome. Think about this for a second. Did you use GPS to get around today? Or maybe check the weather on your phone? If you did, then you've already used space technology. It's kind of crazy how much it's just part of our lives now, right? And that's exactly what we're digging into today, the peaceful uses of space. This fits perfectly into our AMC theme, Science and Technology, Promises and Challenges. We're going to look at the amazing advances, the science, but also the big environmental and business questions that come with it. So, let's get started.
So here's the big question we're going to tackle. I want you to keep this in the back of your mind as we go through everything. To what extent do the commercial uses of space represent more of a promise than a challenge? Basically, are the amazing opportunities of this new space race really worth all the risks? Let's dig into the evidence and see if we can find an answer.
Okay, so here's our game plan. First, we'll look at the promise of discovery. Then, we'll talk about the price of access. After that, we'll get into the perils of progress. And finally, we'll wrap up with how you can build a solid argument for your exams. Simple as that.
All right, first up, the promise of discovery. When we think of space, it's so easy to jump to sci-fi movies. Astronauts and aliens. But the reality is, right now, satellites and probes are these incredible tools that are helping us right here on Earth, and at the same time, totally expanding what we know about the universe.
Before we go any further, we need to get a couple of key terms down. You're going to see these a lot. When we talk about space, we're usually talking about specific lanes or orbits. First, there's low Earth orbit, or LEO. Think of this as the close-in, busy highway. This is where you find tons of observation satellites and these huge constellations. We're talking hundreds, even thousands of satellites all working together, like SpaceX's Starlink. Then you have geostationary orbit, or GEO. This one is way, way higher up. Satellites in GEO move at the exact same speed the Earth turns, so they look like they're just hanging in one spot. Super useful for things like TV signals and weather satellites.
And one of the biggest promises of this technology is something called Earth observation. This is a perfect example. We're looking at an image made from data collected by NOAA. That's the big American Weather and Ocean Agency. Satellites like theirs let scientists see the big picture, They can track sea temperatures, watch the polar ice caps melt. It gives us this incredible planet-wide view of climate change. We're literally using space to help protect our own home.
And here's the cool thing. This isn't just one country doing its own thing. It's a massive team effort. The UK Space Agency report highlights this really well. We've got countries all over the world working together on these mind-blowing missions, like the Euclid mission, trying to figure out what dark matter is, or JUICE, which is heading to Jupiter's moons to see if there might be life. It's proof that space science is really this shared human adventure, pushing the absolute limits of what we know.
Okay, let's switch gears. Part 2, the price of access. This is all about the commercial revolution. For a long, long time, space was basically a government-only club. Think NASA. But that has completely changed. We're in a whole new era now, an era of private companies going to space. And the single biggest reason for this shift? Well, it all comes down to money.
The magic word here is reusability. It's the absolute game changer. Think about it. For decades, launching a rocket was like flying a brand new airplane for one flight and then just throwing it away. Incredibly expensive. But companies like SpaceX came along and figured out how to land their rockets and use them again and again. They didn't just innovate, they broke the entire economic model. And this quote says it all. Reusability is the future. If you want to compete now, you have to do this.
And just look at what this means in practice. The projected cost for a launch on SpaceX's new Starship, somewhere between $2 and $10 million. Now that still sounds like a lot of money, right? But you have to understand, we're coming from a world where a single launch could cost hundreds of millions. This isn't just a small price drop, it's a revolution. It changes everything about who can go to space and what they can do there. This chart really puts it in perspective. Look at the bar for Starship on the left, just $10 million. Now compare that to the Falcon 9, which was already a huge step forward at $67 million. And then look at a traditional rocket like the Atlas V, $160 million. The difference is just staggering. You can see right away why this has thrown the doors wide open for so many more players to get into the game.
And this has real-world consequences. It's not just numbers on a chart. Take this quote, for example. It explains that for satellite companies in India, it can actually be cheaper to pay a premium for a SpaceX launch than to wait in line for their own country's rocket. Why? Because SpaceX can launch so often. It's not just about being cheaper, it's about being faster and more reliable. And in business, that's everything.
Okay, so we've seen the promise and the new cheaper price of getting there. But now we have to talk about the flip side. Part 3, the perils of progress. Because all this amazing progress, well, it comes with a cost. This boom in space activity is creating some really serious environmental and legal challenges that, honestly, we're just starting to wrap our heads around. The biggest, most urgent threat is space junk. All the old satellites, rocket parts, even flecks of paint. It's all up there, whipping around the planet at insane speeds. And this leads to a terrifying idea called the Kessler syndrome. Imagine this. There gets to be so much junk up there that one collision sets off a chain reaction. A piece of debris hits a satellite, creating thousands of new pieces of debris. Those pieces then hit other satellites, and on it goes, like a cascade. The result? Low Earth orbit becomes a lethal, unusable minefield for generations. We could literally trap ourselves on Earth.
And if that happened, wow, the consequences would be catastrophic. And this is not some far-off sci-fi problem. Think about it. We talked about GPS at the start. Well, modern farming depends on it to feed billions of people. Global shipping, air travel, all gone. Healthcare systems would break down. And without military and intelligence satellites, you're looking at a much, much more dangerous and unstable world. The stakes here are, well, they're everything.
So you've got the environmental danger, but there's another huge conflict brewing, and this one is about law and philosophy. The question is simple. Who owns space? And the answers could not be more different. On one side, you have something like the Moon Treaty from 1979. It says space belongs to everyone. It's the common heritage of mankind. But then you have U.S. law, which says the exact opposite. It basically says finders keepers. If a U.S. citizen goes out and gets a space resource, they can own it, use it, and sell it. This right here is the heart of the debate. Are we treating space like a shared global commons, something we all share and protect together, kind of like the oceans? Or is it the next Wild West, a free-for-all, where private companies can stake their claim and get rich? As you can see from this source, a legal journal, we have no answer yet. And whichever way we go will define our future off this planet. Okay, so we've covered a lot, the promise, the price, and the peril. Now for the really practical part. Let's talk about how you take all of this and turn it into a fantastic argument for your AMC assessment.
The best way to structure your paragraphs, honestly, is the PEE method. Super easy to remember. Point, example, explanation. First, you make your point in a clear sentence. For instance, the commercial space race is possible because reusable rockets have dramatically lowered costs. Simple. Then, you back it up with an example from the sources we've looked at, like SpaceX's Starship aims to lower launch costs to as little as $2 million. And finally, the most important part, your explanation. This is where you connect the dots and explain how your example proves your point and helps answer our big guiding question. If you follow that structure, your arguments will be sharp, clear, and very well supported.
And here's a pro tip for getting a better grade. Use the right vocabulary. When you talk about the economics, don't just say cheaper rockets, say reusability or commercial recovery. When you talk about the environmental dangers, use the term Kessler syndrome. Using these specific terms shows the examiner that you really understand the topic on a deeper level. It makes your arguments sound way more professional.
All right, let's wrap this up. Time for our conclusion. So, where have we landed? Well, it's pretty clear that there are two sides to this coin, isn't there? On one side, you have this amazing scientific promise, all powered by private companies and their new technology. But on the other side, that same progress is creating massive environmental headaches and sparking this huge fight over who gets to own and control what's up there.
So let's go back to that original question. Is it more promise or more challenge? Well, our analysis shows the answer is that you really can't have one without the other. The promises and the challenges are completely tangled together. The very things that make it so exciting, the cheaper rockets, the constant launches, are the exact same things creating the space junk problem and the legal battles. They are inseparable.
So I'll leave you with one last thing to think about. For all of history, it was countries, governments that made the rules for new frontiers. But today, a company like SpaceX has more influence in space than most nations on Earth. So who gets to write the rules now? The companies pushing the limits, the governments who are supposed to represent the people, or should we have some kind of global agreement for all of humanity? That right there is one of the biggest questions we face. Thank you for joining this Explain.